So we're given that the height of a ball in meters, t seconds after it's thrown off a building, is given by negative 9.8 t squared plus 20t plus 50. Very first question is, how tall is the building? Well, that's when right at the instant before the ball is thrown, so h of 0, we find out is 50. So the building is 50 meters tall. Do not forget your units. When does the ball hit the ground? Well, that's going to be when this is equal to 0. Negative 9.8 t squared plus 20t plus 50. And this is going to probably not factor very easily, so we'll go ahead and use the quadratic formula. And I'm going to go ahead and I like my coefficient on t squared to be positive, so 9.8 t squared. It doesn't need to be, just a habit. Okay, and we're going to plug these into our quadratic formula. So now I have 20 plus or minus the square root of 20 squared minus 4 times 9.8 times negative 50. Remember to bring your signs with those. All over 2 times 9.8. Okay, let's use our calculator to help us calculate those. And I'm going to go ahead and just put everything in at once. And we have our numerator, so 20 plus, I'm going to do the plus first, square root of 20 squared minus 4 times 9.8 times negative 50. There's our numerator, divided by. Now, because if I have the denominator written, I do need to put it in a set of parentheses, 2 times 9.8. And I see that it lands, one of my values is, t is about 3.5 seconds. It's going to land. Now we have another value coming from this, and that is when I do 20 minus. And I do get a value. I get another value, I get negative 1.46, but negative doesn't make sense in the context of this situation, so we're not going to worry about that answer in this case. Okay, next thing, what is the max height and when does it reach it? Well, our graph is a quadratic, so its maximum height is going to be at its vertex. To calculate the vertex, we can use the formula minus b over 2a. So minus, now b is 20, a is negative 9.8, and that has to get multiplied by 2. So, calculating that, 20 divided by, I'm just going to put them in as positive, that's 9.8. So, the maximum height is going to occur at roughly about 1.02 seconds. Now, to get the maximum height, I'm going to plug that value into my quadratic. So this is when it reaches its maximum height. Its maximum height is going to come from plugging 1.02 seconds into my function. So, one thing I can do to save all my decimals is right here, down at the bottom, I've got the answer key. So what I'm going to do is I'm going to put in negative 9.8 times, now I'm going to do second, that answer key at the bottom that I showed you, squared, plus 20 times second answer plus 50. So that automatically puts that number in for me. And there's my maximum height, about 60.2 meters. So the max height is about 60.2 meters above the ground. Now, what about when the ball is 20 meters above the ground? Well, remember what our function does. It gives the height above the ground as a function of t, so we're going to set that equal to 20. So we're going to have 20 equals negative 9.8 t squared plus 20t plus 50. So once again, I have a quadratic. I'm going to get equal to 0, and I'm going to do it by bringing everything over here. So 9.8 t squared minus 20t minus 30 equals 0. So once again, I'm going to use my quadratic formula. So t equals 20 plus or minus the square root of 20 squared minus 4 times 9.8 times negative 30. It's very similar to the one we did just a little bit ago, over 2 times 9.8. In fact, so similar that I'm going to use that one. If I do second entry, it brings up some of my old answers. So I do second entry a few times, and there's back to my quadratic formula. Biggest thing is this guy has to get changed to a negative 30. And notice this is my answer for minus. So I do get a negative value for t. So one of my values is negative 1.005 to a couple decimal places. But that doesn't make sense in this context. So there's only going to be one place where it's going to be 20 meters. That makes sense in this context. And let's change that to a plus. And that's at about 3.04 seconds. Not too long before it's about to hit the ground.